Hello students. Integration is a very important and vast topic. Today we are going to start with the first part. So watch the video till the end and subscribe to the channel. The concept of integration. We have already studied differentiation, which was to study the rate of change. Integration is basically the inverse or reverse process of differentiation. Instead of differentiating a function, we are given the derivative of the function, and if we want to find its primitive, that means the original function, then this process is called integration or anti-differentiation. The formula that gives all these antiderivatives is called indefinite integral of the function, and such a process of finding antiderivatives is called integration. Basically, integration is the reverse process of differentiation. And for example, if we want to know the instantaneous velocity of an object at any instant, then to determine the position of the object at that instant, we use integration. We know the velocity, but we want to find the position, we use integration. You might be remembering that if suppose you are given the position, you can find the velocity by differentiation. This is a reverse process. If you are given the instantaneous velocity, you can find the position by integration. Basically, there are two types of integration, indefinite and definite. Indefinite integration, it is used to find a function whenever the derivative is given to us. And here no limits are there. Indefinite integration, basically limits are there. It is bounded. That means it is used to find the area bounded by the graph of a function under certain conditions. We will study one by one to get the clear idea. So integration is the inverse process of differentiation. Basically, integration means summing up. If you are having a discrete series, you use the summation. For continuous, you can use integration. Now, functions with the same derivatives differ by a constant. For example, if you have x cube, then the derivative of x cube is 3x square. The derivative of x cube plus 4 will also be 3x square. That means you have a constant c. So there exist infinitely many antiderivatives for each of these functions, which can be chosen by taking different values of c. So c is called arbitrary constant. So when you integrate a function, at last you put plus c for the answer. That means if I am adding any other constant c, then also the integral will remain the same. You know the symbol for integration. That means suppose if I am having y is equal to integral fx dx, then fx will be called as the integrand. For example, derivative of x cube by 3 plus c. X cube derivative 3x square. So 3x square by 3 means x square. Correct? Constant derivative is 0. So if you know that derivative of x cube by 3 plus c is x square. So now the reverse process. If I take integral of x square, it is x cube by 3 plus some arbitrary constant c. See, there are many properties and many techniques of integrating a function. In one by one each of the parts, we are going to see when and how to use these techniques. It is very important when you have to find the integral of a function, then you should know which technique to use. Now basic rules. If you are having sum and difference of two functions, integral will also be sum and difference. Similarly, when you multiply by a constant, so integral of k into fx dx is k into integral of fx dx. If two functions are having the same integral, then the difference of the function is 0. This can be applied to any n number of functions. See, there are many sets of formulae of integration. In each of the parts, as I told you, we are going to see how and which formula to use. The basic integral formulas are integral x raised to n dx is x raised to n plus 1 upon n plus 1 plus c. For example, integral of x cube dx will be x raised to 4 upon 4 plus constant c. Similarly, integral of 1 upon x dx is ln means log with the base e, ln of mod x plus c. Integral of a constant is c into the variable. That means integral of 2 dx is equal to 2x plus c. These three are the basic, very important formulas. So I have kept in a box. Similarly, integral of e raised to x will be same, e raised to x plus c. Other formulas follow from the above formulas. So this is first set is of basic integral formulas and exponential and logarithmic functions. The next set of formula is for the trigonometric functions. Integral of sin x dx is minus cos x plus c. Integral of cos x dx is sin x plus c. I think this can be very clear because you know that the derivative of sine is cos and the derivative of cos is minus sine. So integration will give you the reverse process. Similarly, integral of sec square x dx is tan x plus c. Integral of cosec square x dx is minus cot x plus c. Integral of sec x tan x is sec x plus c. Why? Because derivative of sec x is sec x tan x. Similarly, integral of cosec x cot x dx is minus cosec x plus c. Now other formulas which are there on the right hand side, they follow from this set of formulas. So you can either remember them or use them whenever necessary. Now there are some special integrals, some special formulae which we are not going to use in this part, which we'll be using in the next parts to follow when we use the other different techniques for integration. I've just given this as a set of formulas so that you just get an idea that integration has many specific formulas. A rule for integration which might be helpful in solving some examples. Integral of fx raised to n into f dash of x dx is equal to 1 upon n plus 1 fx raised to n plus 1 plus c. That means if you are having a function which is raised to some n power multiplied by its derivative, and if you find the integral of this, will be 1 upon n plus 1 fx raised to n plus 1 plus c. Similarly, if you are having the function which you have to integrate in the form of some f dash of x upon fx dx, then its integral will be ln means log with the base e ln mod fx plus c. You have seen that there are many formulae for integration and there are basically 3 or 4 methods by which you can find integral of a given function. In this first part, we are going to study integration by substitution and integration using trigonometric identities. First of all, let us understand what is this technique or method, integration by substitution. The given integral of fx dx can be transformed into another form by changing the independent variable x to some other variable t by substituting x is equal to g of t. Correct? It will be clear with the help of an example. See, I have given an example. Suppose you want to find integral of 2x into sine of x square plus 1 dx. Now you have x square plus 1. Suppose this term I substitute as some another variable t. Then when I differentiate both the sides, what will I get? Derivative of x square is 2x. So 2x into dx is equal to dt. So my original function is there. In that 2x dx, instead of that I substitute dt, and instead of x square plus 1 I put t. So now my original integral I will become 2x sine x square plus 1 dx will become integral of sine t dt. See how simple it has become. So what is the integral of sine? It is minus cos. So it is minus cos t plus c. Now again put your t value in it. So it is minus cos of x square plus 1 plus constant c. So now when do we generally make substitution? We generally make a substitution for a function whose derivative also occurs in the integrand. That means what you have to integrate in that, if you are having a function and also its derivative, then in such situation integration by substitution becomes very helpful. What is integration using trigonometric identities? As the title suggests, suppose you are given some trigonometric function in which you can use any of the trigonometric identities and make it simpler, then you first do that. For example, if I want to find integral of sine cube x dx, the first method, by using the identity, I can write as sine 3x is equal to 3 sine x minus 4 sine cube x. You know this formula. So you just put the value of sine cube x from this formula and then you integrate. So now it becomes simpler. The function becomes simpler. So you can integrate and find the answer. Second method is you can use another identity also, trigonometric identity. Instead of sine cube, I can write sine into sine square. For sine square, I can write 1 minus cos square. Then just now we have seen the method of substitution. Let cos x is equal to t. So its derivative is again there in your integrand because derivative of cos x is minus sin x. So instead of minus sin x dx you can put dt. Correct? So now what will your function become? It will, instead of sin x you have to put sin x dx, you have to put dt, but it is minus sin x dx is dt, but you have sin x dx, that means it is minus of dt. But instead of taking minus, what you can do is instead of 1 minus cos square you can write cos square minus 1, so it is t square minus 1. So when you substitute this you will get integral of t square minus 1 dt. So now again it has become simpler, and when you simplify you get the answer. Also remember, these two answers look different, but basically if you simplify each of them using the trigonometric identities, then both of them will give you the same result. So this is just to show that we can use any of the trigonometric identities to solve an example. We now start with the examples. The first example, you have to find the antiderivative of integral just by inspection, that means just by looking at the function using the concept. This is just to understand the concept, otherwise fine, you can use all the integration formulas. So suppose you are having sine 2x minus 4 e raised to 3x. You want to find its integral, that means you want to find a function whose derivative is the given function. Now you know derivative of cos is minus sine, correct? And suppose if you are having cos 2x, then its derivative will be minus sine 2x into 2. So to get sine 2x from that, what you need to do is you have to divide by minus half. So this is the first term. Second term, minus 4 e raised to 3x is there. You know that derivative of e raised to 3x is e raised to 3x into 3. So from that, if I want just e raised to 3x, I have to divide by 3. In very simple language, the derivative of minus half cos 2x minus 4 by 3 e raised to 3x is the given function sine 2x minus 4 e raised to 3x. So just by inspection we have found this. Also, if you use our regular integration formulas, you are going to get the same answer. Second one, root x minus 1 upon root x whole square. So first of all, a minus b whole square expansion. So x plus 1 upon x minus 2. X, you know integral x raised to n, integral is x raised to n plus 1 by n plus 1. So x integral is x square by 2. 1 upon x integral is log mod x or ln. Ln over here means log with the base e. 2 integral is 2x, correct? So the integral of the given function is x square by 2 plus log mod x minus 2x plus c. In short, if you differentiate this function, you will get the original function. This was just to understand the concept of integration. Henceforth, we are directly going to use the formulas. In the second example, you have to integrate the given functions using the simple rules. First one is integral of 2 minus 3 sin x upon cos square x dx. First thing is we simplify it. So it is, first term is 2 upon cos square x, which is 2 sec square x. Second term is 3 into sin x by cos square x, which is 3 sec x into tan x. You know that integral of sec square is tan and integral of sec x tan x is sec x. So simple trigonometric integrals we have used. So the answer is 2 tan x minus 3 sec x plus c. In the second example, it is given that if the derivative of the function of some function fx is 4x cube minus 3 upon x raised to 4 such that f of 2 is 0, then find the function fx. You know that when you take integral of derivative, we will obviously get the original function, correct? Because both are reverse processes. So you take integral of the derivative of fx, so that will give you just the simple function fx. Integral of 4x cube minus 3x raised to minus 4. 4 into integral of x cube. Integral of x cube is x raised to 4 by 4. 4 gets cancelled out, so it is x raised to 4 minus 3 into x raised to minus 4 plus 1, which is minus 3 upon minus 3. On simplification, you get x raised to 4 plus x raised to minus 3 plus c. Now, to find the original function, you need to have the value of constant, and they have given one more information, f of 2 is 0. So in f of x, what we have obtained, put x equal to 2. You will put x equal to 2 and equate it to 0. So you will get the value of constancy, which is minus 129 by 8. So now our actual function is fx is equal to x raised to 4 plus x raised to minus 3 minus 129 by 8. This is our original function which we need to find. Next example, prove that integral sec x dx is equal to log of mod of sec x plus tan x plus c. Now basically this is one of the formulas which you might use as it is in other examples also. Let us prove this. What we are given is integral of sec x dx. Now sec x you can write as sec x into sec x plus tan x upon sec x plus tan x. You are multiplying and dividing by this term. Now we will over here be using the method of substitution. So put sec x plus tan x is equal to t. Take the derivative on both the sides. So it will be sec x derivative is sec x tan x. Tan x derivative is sec square x. So it will be sec x into bracket tan x plus sec x dx is equal to dt. So now you can see that in the original integral, just put this value sec x plus tan x, you put t, barabar, and sec x into tan x plus sec x dx whole numerator you take it as dt. So what do you have is dt upon t, and you know that integral of this type of function, integral dt upon t, is log mod t. Again replace the value of t by sec x plus tan x. So this is equal to log of sec x plus tan x plus c. So basically we have used the method of substitution here. Let us integrate some other functions. Now remember, in this part we are studying the method of substitution. Sometimes you can see that it makes the problem really easy. First example is you have to find the integral of 1 upon x into log x raised to m. X greater than 0, m not equal to 1. Now here substitute log x as t. Now first thing is, how will you decide that you are going to use this method? As I told you, when you are having a function and its derivative both in the integrand, then this method will be useful. You know that derivative of log x is 1 upon x. So in this particular sum you are having 1 upon x also and you are having log x also. So it should strike to you that substitute log x as t. Take derivative on both the sides, it is 1 upon x dx is equal to dt. So instead of log x put t, and instead of 1 upon x dx put dt. So your original integral is integral of 1 upon t raised to m. That means t raised to minus m. Integral of t raised to minus m is t raised to minus m plus 1 upon minus m plus 1. Again resubstitute the value of t as log x. So you will get the answer. Second example, e raised to 2x minus e raised to minus 2x upon e raised to 2x plus e raised to minus 2x. In this, substitute e raised to 2x plus e raised to minus 2x as t. That means your denominator as t. Take the derivative on both the sides. E raised to 2x, derivative is 2 e raised to 2x. Similarly, e raised to minus 2x, derivative is minus 2 e raised to minus 2x. Taking out 2 common, you can see that you will be directly getting the numerator. So if you want the numerator, just you divide by 2. So your original integral will now become half integral of dt by t. But you know 1 upon t integral is log mod t. So the answer is half log mod of t, which is e raised to 2x plus e raised to minus 2x plus c. Next example, integrate x plus 1 into x plus log x whole square upon x. Here substitute x plus log x as t. So taking derivative on both the side, 1 plus derivative of log x is 1 upon x. So 1 plus 1 upon x dx is dt. Now our original function, it is x plus 1 upon x. So that you can write as 1 plus 1 upon x. So it is 1 plus 1 upon x into x plus log x whole square. So now after substitution, it has become 1 plus 1 upon x dx. Whole thing is dt. So our original function is now integrate t square dt. that is t cubed by 3. Again replace the value of t. See how simple it has become. So the integral is x plus log x whole cube upon 3 plus c. Find the integral of 1 upon 1 plus cot x. First thing is, let us simplify this function. Cot x is cos x upon sin x. So after simplification you get sin x upon sin x plus cos x. Now what you do is you multiply and divide by 2. So take half outside. It will be 2 sin x upon sin x plus cos x dx. Now again this 2 sin x you write as sin x plus sin x. But how will I write this? Sin x plus cos x plus sin x minus cos x upon the denominator sin x plus cos x. So now what will happen is I have made two terms. First term is sin x plus cos x upon sin x plus cos x, that is 1. And the second term is sin x minus cos x upon sin x plus cos x. Now I think after this step the idea would be clear that substitute sin x plus cos x is equal to t. We have seen an example of this kind just previously. So now sin x derivative is cos x is minus sin x, so cos x minus sin x dx is dt. This is the first method. Remember, we will see another method also. So now the integral of the given function, first of all integral of 1 is x and outside half is there, so it is x by 2, first term. Second term minus half into integral of cos x minus sin x upon sin x plus cos x dx. What I have done is, instead of sin x minus cos x, I have written cos x minus sin x and I have taken that minus sign outside. So now I can use my substitution. It will become minus half into integral of 1 upon t dt, and that you know it is log mod t. So the integral is x by 2 minus half log mod t plus c. Again resubstitute the value of t and you get the final answer. Again we will see a next method. In the second method, if you remember, I had told you there is a rule that integral of f dash x upon fx dx is log mod fx. So this will directly actually give you the answer. So after the first step, when you need to find the integral of sin x minus cos x upon sin x plus cos x, basically it is of the type f dash x upon fx. If your fx is sin x plus cos x, what will your f dash x be? It will be cos x minus sin x. When you take minus sign outside, it will be sin x minus cos x. So using this rule, directly we can get that the integral is, first term obviously x by 2, second term minus half into log of mod of sin x plus cos x plus c. Next example, x cube sine of tan inverse of x raised to 4 upon 1 plus x raised to 8. You have to integrate this function. Now it seems a little bit complicated, but first thing is you make your substitution. Let tan inverse of x raised to 4 be t. This will simplify the whole part. So now tan t will be x raised to 4. Now differentiate both the sides. Derivative of tan is sec square, so it will be sec square t dt is equal to derivative of 4 x raised to 4 is 4x cube. Now you are having the denominator as 1 plus x raised to 8. So basically x raised to 8 is x raised to 4 square. So it is x raised to 4 is tan t. So it is 1 plus tan square t, and that you know it is sec square t. See, now this should strike to you because you want to convert the whole thing in the form of t, your new variable t. Now multiply and divide by 4. So your integral will be 1 upon 4 into numerator, it is 4x cube sine of tan inverse of x raised to 4 upon 1 plus x raised to 8 whole dx. Now substitute your values. Instead of 4x cube dx, you will be writing it as sec square t dt. So it will be sine t into sec square t upon 1 plus x raised to 8, that is also sec square t. It will get cancelled out, so ultimately it is 1 upon 4 integral of sine t dt. So the answer is Integral of sine is minus cos. So it is minus 1 upon 4 cos t. But what is t? T is tan inverse of x raised to 4. So replace that value, we will get the final answer. Next example, find the integral of the function root tan x upon sin x cos x. Here substitute tan x is equal to t. So what is the derivative of tan x? It is sec square x. So sec square x dx is dt. Now we are given the original function root tan x upon sin x cos x. Now see, you have to multiply and divide by cos x. Why have you to do this? Because just by looking, you will come to know that since you have substituted tan x as t, what you need is sec square x dx. So, you need sec square x dx in the numerator, means 1 upon cos square x dx. Already there is a cos x in the denominator. You need one more cos x. So, that is the reason why you need to multiply and divide by cos x. So, this is just by practice you will come to know. So you multiply and divide by cos x. So it will be root tan x into cos x upon denominator is sin x into cos square x. 1 upon cos square x is sec square x and sin x upon cos x is tan x. So now what you have is root tan x upon tan x into 1 upon cos square x. So instead of 1 upon cos square x dx means sec square x dx, you put dt and root tan x upon tan x, that is root t upon t, or that is 1 upon root t or t raised to minus half. T raised to minus half, integral is t raised to minus half plus 1 upon minus half plus 1, means it is t raised to half upon half. So when you simplify, it is 2 t raised to half plus c. Put the value of your t. So the final answer is 2 tan raised to half x plus c, or 2 root tan x plus c. See, we have discussed examples based on method of substitution and why we need to make that substitution. Do like and share the video and subscribe to the channel for the other videos on integration, in which we are going to study the integration by parts and integration by partial fractions.